Hello, ladies and gentlemen, and welcome to Algebra 2 Distance Learning here with Mr. Hagedorn. Our lesson for today is talking about the fundamental counting principle, permutations, and factorials. The two methods that you see on the screen in front of you are the tree diagram method, which I'm sure all of you are very familiar with, and then the other one is what we will talk about as the fundamental counting principle. So if we take a look at this and we put in our choices, we have white bread and we have rye bread. And then our choices for the meat that we have here are ham, turkey, and bologna. So with these, I'm just going to put in the letters. What we have here are distinct products based on the choices that we have. So notice the first one was white bread and ham. Obviously gives us a white bread and ham sandwich. Well, then we have white and turkey. And we also have white and bologna. Then down below we have rye and ham, we have rye and turkey, and we have rye and bologna. If we count the number of sandwiches, we would be left with 6 different combinations that you could eat. The second method simply says we multiply them together. There are 2 types of bread times 3 types of meat, which gives us 6 sandwiches. The second method, as it says here, is known as the fundamental counting principle. And a basic definition for that would be a product of choices. Whatever you are given is a product of choices. So if we take a look at the example down below here, taking a look at it from the standpoint of the fundamental counting principle only, because this is the one that would obviously be most useful. Shoreland at this point in time has 2 different game jerseys and 2 different game pants. If we purchase a new gray jersey, white pants, and gray pants, the number of combinations would increase. How many? Let's take a look. As it stands, we have 4. But if we add a new jersey, so if we have 3 jerseys, and we take that times now the 4 pants that we have, that would take us up to 12 uniforms that we would be able to play with on Friday night. So by adding a choice to each, we have increased our output or increased the number of choices we have in the end. So let's just go through a few examples. A lot of what we're going to see in this unit deals with word problems that show how we would use this. So at a blood drive, we have 4 types of blood. We have 2 RH factors, and we have 2 genders. So the question is, how many different ways could the blood be labeled? Well, we multiply them together and we end up with 16 blood labels given in that scenario. Again, product of choices. The next example talks about a pin. Now, a PIN is your personal identification number, and many of you have it on your bank card. So the first example asks the question, if you are given one at random, and it says each of the digits is a whole number from 0 to 9, how many different 4-digit PIN numbers could we have? Well, in this case, if we did this, it would be 10 times 10 times 10 times 10. So that would give us 10,000 unique pins. But now let's say, for example, that we say the digits cannot be repeated. Then the question I would have for you is this: how many different pin combinations would we have if there is no repetition? So in this case, that means the first one would have 10 choices, then 9, then 8, and then 7, because each of the previous ones takes away one of the choices that they would give us, which would leave us with 5,040 unique pins. So as you can see right away, repetition and non-repetition makes a difference. So now the next example that we have is talking about license plates. The Alaskan license plate has 3 letters followed by 3 digits. The first question is, how many choices would we have if they could be repeated? Well, for the letters, it would be 26 times 26 times 26. And for the numbers, it would be 10 times 10 times 10. Because if they can be repeated, if they're all there, then it would work out just fine. And that would leave us with 17,576,000 license plates. But now let's say, like we did with our PIN number, we take out repetition. Say they can't be repeated. Well, then that would give us the following scenario. 26 times 25 times 24 for our letter choices, with them being taken out as we go. And then 10 times 9 times 8. Again, each unique scenario from the previous one losing a choice. And that would leave us with 11,232,000 license plates. So again, be aware that repetition versus non-repetition is a big difference. And the last example that we have here says that there are 8 runners running in the 100-meter dash in the Olympic finals. So in how many different ways can the runners finish the competition? And then in how many different ways can they finish first, second, and third? So first one, how many different ways can they finish? Well, then we have to start with no repetition, because if you're first, you can't be anything other than first. So this would give us 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which would give us a grand total of 40,320 unique ways of finishing that race. Sorry about the pause there, ladies and gentlemen. I was having technical difficulties. Now, the second part says, in how many different ways could you finish in first, second, and third? So for this, really all we're looking at is the first 3 parts of our original product. And the reason that we don't care about the rest is because that's fourth and beyond. So in this case, that would leave us with exactly 336 unique ways of coming in first, second, or third for that race. So now we're going to talk about permutations. Permutations, ladies and gentlemen, are specific orders for different groups. So for instance, if you're given 3 letters A, B, and C, like we saw before, there are 6 permutations for that. We have ABC, we have ACB, we have BAC, we have BCA, we have CAB, and we have CBA. Each one of those is a unique order for those specific 3 letters. Then the next thing talks about a factorial. When you see the number with the exclamation behind it, it's read that number factorial. So in this case, it would be 3 factorial. Factorial simply means you take the number that is given and take it times every integer below it down to 1. So the number of permutations of n distinct objects is n factorial. So with this, ladies and gentlemen, we can actually figure these out on our calculators. So first of all, let's figure out what we're going to do. It says there are 10 teams competing in the bobsled finals for the Olympics. How many different ways can the bobsled teams finish? Well, we'd figure this one out by saying 10 factorial. And the second one, very similar to what we had up above, how many different ways could they finish in first, second, and third? That one we're going to figure out by just simply taking 10 times 9 times 8. So in order to do this, ladies and gentlemen, we are simply going to use our calculators. So for those of you who have TI calculators, the TI 84, 83s, it would look something like this. So we punch in the number first. We punch in the number 10 because that's the number we're dealing with. Now the factorial symbol is found under the math menu. So we hit math, we go over to probability, and we go down to number 4, the exclamation point, and we hit enter. So in this case, that would leave us with 3,628,800 different ways for those teams to finish in order from top to bottom. As far as the other one is concerned, the 10 times 9 times 8, that would simply, that you could do on your calculator as well, 10 times 9 times 8. And that would leave us with 720 unique ways for them to finish first, second, or third. Now this, ladies and gentlemen, leads us right back into what we're going to be talking about here for our permutations. So the number of permutations of R objects taken from a group of n distinct objects is given as NPR, which is n factorial over the difference of n and r factorial. So in this case, and in all of these, again, we have a number that we can use, and we also have our calculators, which we're going to go back to right now. So if you take a look at the first example, and this will be the one that I show on the calculator, 5p3. If we take a look back at our calculator, we're going back to that same menu. So in this case, we punch in the first digit, which is our n. Then we hit our math button again. We use our arrows, we go over to the probability menu, and we come down to number 2, NPR, and we hit enter. We then punch in the second number, and we end up with 60. The way that we would figure that out very simply is taking 5 factorial over 5 minus 3 factorial, or 5 factorial over 2 factorial is what it ends up being, which gives us 60. So now with that, ladies and gentlemen, we would be able to figure out different types of permutations and combinations that would go along with. So the last one, ladies and gentlemen, that I would like to show you, and the other examples are there for you to use as well. The last one I'd like to talk about is anytime you have repetition, okay? So with repetition, what we have to take into account is, very simply, how many repetitions do we have? So if you take a look at the letters red E and green E and put it in with Y, there are 6 permutations that you could have there because you change red and you change green around and you have a new order. However, if you take the E's to simply be E's and you don't care about their color, then there are only 3 distinct permutations that we would have. We'd have EYE, EEY, and YEE, okay? So with that, we come across a permutation with repetition. Anytime you have a permutation with repetition, okay, what you are going to do is the following. You are going to take n factorial and divide it by any repetitions that you would have. So in this case, it would be S1 factorial and S2 factorial. So the example that I'm going to use with you here, ladies and gentlemen, is the word banana. Okay? If we take a look at the word banana, in that we have 6 letters. So the top number would be 6 factorial because we have 6 distinct objects. Then we are going to divide that by the number of repetitions. So in this case, we have 1, 2, 3 A's, and we have 2 N's. So what that leaves us with then, ladies and gentlemen, is a very simple problem for us to figure out. So in this case, if we were to write it out or we were to think it, it would be 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. If you remember back to basic math, these would cancel out with those. That would leave us with that. Everything on the bottom is canceled out, and it leaves us with the top number, which would be 60 permutations. All right, ladies and gentlemen, there is our introduction into permutations, combinations. If you do have any questions, please ask in class time. We'll go through any problems that you may have on worksheets, which I will get to you as well. Again, do the best with a bad situation, ladies and gentlemen. I hope you're staying healthy and safe. Lord's blessings on your day, and we'll talk to you soon.